So let's look at this first row of examples. I'm going to kind of show you, don't write on your paper yet, I'm going to kind of show you why the answer is what it is, and then we'll kind of talk a little bit about a shortcut. When you have radicals or square roots, this square root could be written as negatives or square root of 7 times square root of -1. And we know, because of the definition of imaginary unit, the square root of -1 is I. So really what I have is I times the square root of 7. And the way that we write this is I square roots of 7. So kind of like if you had x times 2, you would write 2x. Well, same thing here. You always put the imaginary in front of the radical. Now, I actually do just kind of a little shortcut here. Anytime I see an I under a square root, I don't break it apart and waste that step. I just take the square root of this and the square root of this. So when I see an I under a radical, or excuse me, a negative under a radical, I know that that puts an I out front and then that disappears. So what's left is I square roots of 7. So look at this next problem. Using that shortcut, when I see a negative under a radical, I know that the negative is going to cancel out and put an I on the outside. And then the square root of 16 we know is 4, so it's I times 4, which we would write as 4I. Look at the next one. The square root of a negative is I, and then I have to think about 18. 18 is 9 times 2, and the square root of 9 is 3. So my answer would be 3I square roots 2. Look at the next one. We could also have variables under here. Same thing happens. The square root of a negative is I, so my answer would be I square roots of x.